With the new edition of the Petrozelli textbook, we have an assessment called ABAs, Application-Based Activities. And with these, there are 5 of these activities where students are presented with a real-life problem, and they must walk through what the technician would do in that scenario. And it's really about helping reinforce the troubleshooting process. So students will pick an avatar. It's going to give them some brief information about what to expect in this assignment, the objectives that they're covering, and how they're scored for these assignments. And this particular activity is going to walk students through distinguishing between whether there's a physical failure or a programming failure, and the steps are involved with this. So we'll start off with Janelle, our machine operator. She's having issues on the assembly line, and she'd like the maintenance technician to come help diagnose the issue. When she starts up the machine, the numbers on the touch screen for her position readout are jumping all over the place, and it's causing the system not to start up properly, and it appears the positioning is off. So the first thing the student's going to have to determine is that it's too early to know what the issue is. We're going to need to dig in a little bit deeper. So it reinforces that the students need to keep an open mind about what the issue might be. So that being said, they have to determine what are they going to do next. And we're going to have the machine operator perform another startup cycle so the issue can be demonstrated to the maintenance tech and he can get an idea of what the problem is. When they do that, Jason's going to make the correlation between the positioning error on the screen and the physical motion of the control system, and that it is not correct. He knows the feedback into the controls as an analog sensor, and that the student has to decide what to do next. So in this case, the student is going to need to perform the proper lockout tagout. So you can see the system is reinforcing to the students the safety issue and the importance of this step. So next they're going to dive into the control panels and wiring to take a closer look where he's going to do a safety and visual inspection and then perform pull tests to look for loose wires. He's going to compare the wiring on the sensor in question against the electrical prints to ensure that everything is properly wired and to confirm his understanding of the machine. So now Jason has to determine what should he do next in this scenario. And if the student chooses the incorrect answer, which I'll do here, you can see they're going to get some feedback on this. So it's going to let them know that while the machine is still locked out, they should look on the external side of the machinery for any obvious signs of wear and tear, etc. So next, Jason's going to perform the visual inspection on the outside of the machine. However, he does not find the issue. So what does he need to do next? So at this point, the technician has had the operator look at it. He's done all that he can to verify the system. There's no obvious physical faults with the machine. Now he needs to call the control engineer to get additional guidance before they can go in and start messing with the program. And the goal here is to reinforce to students what they can and can't do and at what point they need to call for help. So next, the control engineer is going to remove the lockout tagout and restart the machine so they can see the issue. So they're going to do that, do some troubleshooting to show how a technician would actually troubleshoot this with the appropriate pieces of test equipment. And so I'm going to have to choose the best choice to verify the output of the analog signal while it's being started up. So we'll choose the oscilloscope. And as you can see, that's correct because it allows me to visualize the output signals present and see the actual raw signal, which is being read into the control system. All right, so now based on the fact that the sensor data is found to be erratic, I need to determine what conclusions I can make. And in this case, we're going to say that there is excess noise present in the signal. So we let Jason know that you're seeing a lot of noise in the analog sensor. And ultimately, we have to determine what we should tell Jason to do next to help troubleshoot the issue. So in this case, we're going to say all answers are correct. We need to do all 3 of these steps. So we'll check the wire routing, check the incoming power to LVDT sensor, and check the grounding on the LVDT to ensure that there is not a ground loop. And then Jason's going to radio back letting us know that he found the position sensor input voltage is within the acceptable range and that the sensor is properly grounded based on wiring practices. However, the signal wires are indeed running the same wire bundle as the high voltage motor power wires. So now we need to select all that apply that can address this particular issue. And determine which sensor output type we should use. So we're going to use the one that's a much better option for areas that are susceptible to electrical noises. And based on that agreement, we need to determine what things need to be done to get this change implemented on the machine. So here you can see I chose incorrectly. Again, it's going to give the student some feedback, letting them know all of those choices were actually correct. So now it's time to meet back with Jason and discuss the plan of attack, which is ultimately going to resolve the issue for the student and for all parties. So what this exercise is doing is tying in why the PLC class students have to learn about the different types of sensors, both on the voltage and current centers, and then how they're impacted by the environment. So in class, students might hear about the components in discrete lectures. One day it's about sensors, then it's about interferences between wires, then it's about PLC. But this exercise ties it all together so that students can see why they are learning those skills. In addition to walking into the troubleshooting process, we also touch on the documenting piece and how Jason needs to put all of these into his notes. You can see at the end, the students are going to get a score based on how they did. As an instructor, you'll get this information as well. So you can see if there are particular objectives that students are doing really well on. Maybe there's one objectives that the class as a whole is struggling with, and you want to go back and touch on that and clear up any misconceptions.